Hello class, welcome to Electron Configuration, Electron tutorial number 2. We're going to start looking at how do we show where the electrons go, how do we write that, how do we indicate that, and also how do we know where they go. So that's the big question. So we were looking at the 4 types of sublevels, S, P, D, and F, back in the last tutorial. So remember, the S is represented by a spherical shaped dome, 2 electrons to go here in this red shaded region. These gold ones refer to the 2p on the x, the z, and the y-axis. So 6 electrons to go in these gold regions. And then the D's are represented by these green ones here. So third energy level, 18 electrons to go in these pockets of space that sort of wedge themselves between the bluish and gold p sublevels. And then here these maroon ones refer to the spaces that the F electrons are going to be found. So depending on which energy level you might have S, you might have P, you might have D, you might have F, all 4. So let's talk. How do we know where the electrons are going to go? So it all comes down to energy. In nature, whatever takes the least amount of energy is what's going to happen. That's the most stable way, and that's typically the rule. So 1s, if we look at this diagram shows us a rough idea of the energy requirements for an electron. So how much energy does the 1s electron have? It's very, very low. Alright, so the 1s is going to fill up first because it takes the least amount of energy. And then the next electrons are going to fill the next lowest energy, and that is the 2s. And then after the 2s, the 2p takes the next least amount of energy. And then after the 2p, the next one is the 3s, and then after the 3s we go to the 3p. And then you would think, alright, 3p, let's go to the 3d, but no, not so fast. If we look here, the 3d has just a little bit more energy than the 4s, and so the 3d does not fill up next, but instead we add to the 4s. And then after the 4s we go to the 3d, and then we go to the 4p, and then we go to the 5s, and the 4D. So they fill up from lowest energy level, sublevels first, and they work their way up. So we have a nifty flowchart, and this whole principle is called the Aufbau Principle. So the Aufbau Principle works for most elements. There are some exceptions to the rule we're not going to talk about right now. But over 85 elements in the periodic table will follow the Aufbau Principle, and we can use this to accurately predict where the electrons are going to be found. So an easier tool that we can use is the flowchart. The flowchart basically breaks down what we just did on the last slide and makes it easier to follow. So the 1s fills first, and then we snake through. So we start here, follow the snake flowcharts, the 1s, and then 2s, and then 2p, and then 3s, and then 3p, and then 4s, and then 3d, and 4p, and 5s, and 4d, 5p, 6s, 4f. So just reminders, the s's, the s orbitals, the s sublevels can hold 2 electrons. The p sublevels can hold 6 electrons. All the d's can hold 10, and the s can hold up to 14. So these are the maximum values for how many electrons we can place in each one of these sublevels. So if we take a look at, let's say, neon, noble gas neon has 10 electrons, 10 protons. So we need to find where the 10 electrons go, and so we can do that. We start here, so we start filling up the 1s region, the 1s sublevel, outside the nucleus, and so it can hold 2 electrons. So 1 represents the first energy level, s represents the spherical shaped home, and then we're going to write a little 2, a superscript 2. That's not a power, that's just how many electrons are currently residing in the 1s. So we're going to put 2 there, that's the max. And so 2 electrons fill up the 1s. So where do we go next? We go to the 2s, and the 2s can hold up to 2 electrons. So how do we know how many electrons we placed? If you add up these little superscripts, 2 plus 2 is 4, so that tells us we have the homes for 4 electrons. Neon has 10, we need 6 more electrons, and so 2p comes next. And the p can hold up to 6, and so the remaining 6 electrons will go in the 2p. So the electron configuration for neon is 1s2, 2s2, 2p6. Or 2 electrons are found in the 1s, 2 electrons are found in the 2s, 6 electrons are found in the 2p. So what would this look like? This is a model here. I tried to do a 3D model. And so we're going to learn in the next tutorial how to draw arrows and how to do an orbital diagram. But for now, let's just look at the 1s2. So This is neon's configuration. So 2 electrons and a 1s. You're like, whoa, Mr. Lehman, there's no blue shaded area. Where are these electrons at? You got to remember the 1s is inside of the 2s. The 1s is closer to the nucleus. So the 1s would be more here on the inside. And so we would have 2 electrons moving around in this blue shaded space. And then the 2s is indicated by this shaded region. And so we would have 2 electrons moving around randomly in that space. And then we have 2p6. We break it down by orbital, break it down by axis. And so 2p2 on the x-axis indicated by this space. So 1 electron would be in this space, 1 electron would be in this space, randomly moving around. And it's possible they could be in the same space, same side for a split second, but they're not going to hang out there. They want to have their own space if possible. And then 2 electrons would be in the 2p on the y-axis. So 1 electron up here, 1 electron down here. 1 electron here in front of the atom, in front of the nucleus, in the third dimension, and 1 behind. So this gives you an idea of the approximate location of neon's 10 electrons, which once we know the electron configurations and where the electrons are going to be found and how many are going to be found on the outside of the atom, we can give you an idea of how reactive that atom is and what it's going to react with and what ratios in which it's going to react. So if we look at another element, let's do one that's a little bit more complicated. Let's do bromine. Bromine, 35 protons, 35 electrons. Follow the flow chart. Let's find homes for those 35 electrons. So the first 2 go into 1s. The next 2 go into 2s. 2p can hold 6. And then we follow. 3s comes next. We can put 2 electrons in the 3s. And then the 3p comes next. 6 can go in the 3p. And then 4s comes next. There's 2. So how many electrons have we placed? 2 plus 2 plus 6 plus 2 plus 6 plus 2 is 20. So we still have 15 more to go. So after the 4s, we go back to the third energy level, to the 3d. And the next 10 electrons will go into 3d. And then comes the 4p. And so we have 30 electrons so far. We have 5 more electrons left. The p can hold up to 6, but we only have 5 left. So we finish it with 4p5. So the next tutorial we'll learn how to draw the orbital diagrams, and we'll learn the shortcut. Now that hopefully you're getting good at this, we can shorten it up, since once we get to gold and things with tremendous amounts of electrons, it can be very, very tedious and time consuming. So alright, hope you learned something and have a good day.